Good evening. This is meteorologist DT with the video podcast on wxrisk.com for snowstorms for the Thursday, December 28th. It's 11:30 p.m. here in the east. Let's get right to it. A couple of topics we'll be talking about here. The upper air pattern right now over the northern hemisphere, especially North America. Upper air patterns from the famous East Coast snowstorms. And we'll be talking about the January 4th and 5th threat, which has showed up in the last two runs of the European model. And advice about staying calm and skeptical and not getting too hyped up because there are a lot of problems with the European model solution. All right, first we'll look at the snowstorm matrix. As you can see, the next 3 days, all five areas, nothing going on. Days 4, 5, and 6, January 1, 2, and 3, nothing going on at all. And then obviously day 7, 8, or 9, January 4, 5, and 6, there is the potential for a significant snowstorm in I-95 and a moderate snowstorm over the interior of the Northeast, but that's about it. Now, this is one of the rules which I put it together for forecasting winter storms on the East Coast, and this is one of the rules here. Winter storms only happen when the atmosphere at a middle or upper levels are set in particular configurations or teleconnections, weather patterns, which cause the low pressure area to develop and reach significant intensity and size. So seeing a weather model that has low pressure, the L, let's say near the North Carolina coast, does not cause anything. The model reflects the atmosphere. It does not drive the atmosphere. Second rule here, another important rule, weather models do not cause winter storms to happen. The winter storm doesn't occur because the GFS or the Canadian or the European model does something with the low pressure area. The weather models reflect the atmosphere. They do not shape it or drive it or determine it. And obviously this seems like a pretty obvious point, but when you read statements like this, well, the GFS and the European models have a low on the Carolina coast in 7 days. When you see or hear or watch or read something like that, you're listening or reading to somebody who's spending way too much time focusing on the weather models and not what's going on in the atmosphere. Now, the ideal teleconnection or setup that greatly increases the chances of a big East Coast snowstorm is to have the EPO in the negative phase here and the PNA to be in the positive phase. Now these two are on the West Coast, okay? So this is the West Coast pattern. And over Eastern Canada, you want the Arctic oscillation to be negative and the NAO to be negative. And of course, we want the 50-50 low over southeastern Canada. This is the pattern we want for an East Coast snowstorm. This, and this. There are 5 things that we look for. Now, having all 5 of them does not mean you will get a snowstorm. But if you don't have at least 3 of these in place, you're not getting shit. All right. This here's the current atmospheric pattern as of December 28th. Let's take a look at it. And this feature right here, well, this is a big block here over Siberia. And the EPO, which is the area that concentrates in this area here, is neutral. If this block was over here, it would be negative. So it's not. We have a neutral NAO. We have some positive anomalies here a little bit in the NAO. This big upper low here, this is a positive Arctic oscillation. That is not good. There you go for that. So, okay, and on the PNA, we have a very weak, slightly positive PNA right here. Not a big deal. But the hurt was not look good in this pattern right now is this feature. So just want to point that out to you. All right, now 5 days from now, as we perhaps get ready for the East Coast storm, what is the European model doing? Well, we do have a bit of a PNA here, so that's nice. Okay, and the EPO is close to neutral. It's not really negative, but it's getting close there, so that's okay. So those 2 things aren't bad. But again, we have a very positive Arctic oscillation in this phase, and the NAO is strongly positive as well. So those 2 things are negative. The Arctic, let me get it here. The Arctic oscillation is positive, and the NAO is also positive. These are not good for East Coast snowstorms. Now this is what the European is actually doing. This is the Thursday afternoon run. You can see what it does. It runs it up the coast. Now what's interesting about this is about as far east as you can get. The low forms on the operational run by the Bahamas down here. and then it goes straight up the coast, right, like this. So Hatteras, we could pound it east of North Carolina, the eastern third of Virginia, the Delmarva, New Jersey, and then all of New England gets crushed, as you can see. Now notice the European has two lows here. Both of these are both equal intensity, 977 millibars. This is suspect. You are not going to get two lows next to each other. No. Okay, the European, maybe the one near the New York, New Jersey is clear. Maybe this one is clear. Maybe this is the big coastal one. In that case, everybody gets a huge snowstorm in the Northeast, the Mid-Atlantic. Great. But suppose this is the main low. That's a different matter. That's New England. So there you go. The other thing you have to notice here is because of the Arctic air, you have a very, very sharp cutoff line to the snow. So, you know, Richmond, let's say, gets 6 inches. Farmville, Lynchburg get nothing. Philadelphia gets a foot. Harrisburg gets zip. Very sharp cutoff here to the snow. Now, look at the teleconnections here. Now, these are actually from yesterday, but the new one has not changed. Okay? So here we have the Arctic oscillation. Neutral to positive. We'll look at the green lines, okay? The mean. Okay, here is the EPO. Green line, slightly negative, not great. Not horrible, but not bad. This is the North Atlantic oscillation, the NAO. That's positive for this storm. And then here we have the PNA. A little positive, then drops negative. Not ideal, folks. This, you know, I'm just saying, but, you know, there's a reason not to be too excited about this. Now, here's the snow mounts. Wow. Looks huge. Looks great. I love it. Okay? And, of course, we have a lot of Arctic air. The snow is going to stick right away. Cold, very, very cold out. It's going to be that way right through January 4th. And the snow ratios are huge. Yeah, that's like 17 inches east side of Richmond. But, again, look at west of Richmond. Look at this. 6 inches to west of Richmond. Can you believe that? 17 here. Okay? Again, look at the sharp cutoff in Pennsylvania. Allentown, 22 inches. State College, 8. Wow. Okay? Pretty darn impressive. So I just want to show you what this might be happening if this happens. Here's an enlargement for the Mid-Atlantic region. And again, look at the very sharp cutoff in the snow amounts. That's, okay. East of Richmond, 13 inches. West of Richmond, 4. That's a tough forecast to make. I mean, this line could be 50 miles further to the west. Absolutely. It could be 50 miles further to the east. Okay. All possibilities. Now, here's the upper air map on the operationally European, again, Thursday afternoon. What's it doing here? The problem here, we have a nice ridge on the west coast. That's great. Okay, there's your PNA ridge. That's great. EPO, no, that's neutral. Okay, but the problem is, see the black line? That's the trough axis, so the low forms here. Ideally, the trough axis should be this, further to the west. The black line is too far to the east for a big East Coast snowstorm. Now, that could shift easily in the next 5 days. But right now, I'm not impressed. And you can see that even more here if we look on the one from Tropical Tidbits. This is the EPS, European Ensemble. And you can again see here, this is the operational run, and the low is going to form here. Oops, excuse me, like in this area. It's too far to the east. This, if the trough axis is here, the black line, if that's correct, the low forms here, in which case everybody gets a huge snowstorm. So I'm not impressed. It's got too far to the east is what I'm saying. Now, this looks great. This is the ensemble mean. Look at the green. Look at all the big red L's they are showing the snowstorm off the New England coast. The question is, how does this happen? A lot of people aren't looking at this. Does the low form here and go like this? Great. Everybody gets a huge snowstorm. Yay! Big snow, big snow. Or does the low form off the Bahamas, in which case the low does this? That's too far off the coast. Got to think about these things, folks. Here, another example of it. Look where the low is on the evening and going the morning of January 4th. That's way off the Hatteras coast. Now, yeah, there are a few members, a few red L's close to the coast. Yeah, I see that. But a lot of them are way out here. So it goes from here to here. That's not a great track. That's good for eastern New England. Right along the coast, maybe. Maybe. And if we look at the ensemble mean, there it is. Now, again, I'm even generous with this. The actual low is here, but I place the low here. And you draw the line. That's really far off the coast for a huge snowstorm in the mid-Atlantic. Again, eastern New England, Long Island, great. Okay, Maine, Nova Scotia, New Hampshire, terrific. Mid-Atlantic, I'm not seeing it. Now here's the 18Z, 12Z GFS is way out to sea to the east, of course. What else is new? Now let's take a look at some other snowstorm patterns. This is February 4th to 7th, 2010. Now, what did this do? You may remember this one. This was the first big North Virginia, D.C., Baltimore snowstorm. Got close to Philly and southern New Jersey. Now, that purple stuff represents 14 to 20 inches of snow or more. We all remember this storm. A lot of us do. Okay. How did this storm happen? Well, we had a split flow pattern. What does that mean? We have one jet stream here, and notice the other jet stream is here. The flow is split here and here, a split flow. We have a big 50-50 low right there. You can see it. All right. And here's our trough in the Midwest. I mean, the plain states. And these two features are going to phase. And that will produce the storm. There we have it. Ridge on the west coast. We have a 50-50 low over southeastern Canada. A big 500 low over Virginia, the Appalachians. Right here. You can see that. And that produces the surface low, which produced the snowstorm and close to blizzard conditions. Notice this huge upper low over southeastern Canada. See that? That's the 50-50 low. There it is for you to see in its glory. And if we look at the large scale features, we can see our negative NAO right here. You can see that right there. See the NAO right over block over Greenland. There's our 50-50 low right here. There's the trough on the Midwest coming in right in here. And again, notice the flow is split here and here. A big split in the jet stream pattern. So this is what produced that snowstorm. This is February 10 to 12, the one which occurred a few days later. And then we can see what the snowstorm did here. This is Northern Virginia up to Philly, up to New York City, Baltimore, New Jersey, eastern and southeastern Pennsylvania, northern Delaware. Significant, huge snow amounts, anywhere from 10 to, 20 inches in some places. And this was the upper air map. And we can see our features again. There's the Greenland block right here, the negative NAO. This is our huge 50-50 low right here. This thing's a monster. There's the upper low coming in this way. And again, look at the split in the jet stream. Here and here. Split flow, dangerous, big snowstorm pattern. And the Arctic oscillation is negative. So there we go. So we have everything we want here. And of course, this upper level low is going to catch this one, going to form a big storm on the coast. You'll see that in just 1 second. And then January 22nd, this was the blizzard back in January January 2016. Now in this pattern here, we have a monster 50-50 low, a huge low over southeastern Canada. Look at this monster. Wow. All right. And we have a split flow. Look, there and here. The jet stream is split, again, into two branches. The northern one and the southern one. And that helps make a snowstorm. And then as we go further in time, this was January 19th, 2016. This is January 21st. We still have our huge 50-50 low right here. We have a blocking right here over Greenland. We have the southern trough. Here's our southern energy. And there's the northern energy, the northern branch and the southern branch. Split flow pattern. And now the Arctic oscillation here is positive. So again, but we have the 50-50 low and the NAO. So you can get a snowstorm if you need to get one of those things negative, the Arctic oscillation or the NAO. And that really helps your chances. And this is how the upper air pattern developed. Here's our huge 50-50 low right here. Here's the split flow pattern. There's the southern branch. Here's the northern branch. You see two distinct splits in the jet stream. There's the upper level energy. It's going to move to the east coast and make a huge blizzard, which is what it did in January 24th, 2016. So finally, this is December 19 to 20, 2009. So this is the upper air pattern, and this was a classic snowstorm. Many hit Virginia very hard, including the Richmond area. Huge block pattern right here over Greenland. So we had a nice strong NAO, and we had a split flow in the pattern. Here, the southern branch, and here's the northern branch. There's our gargantuan 50-50 low. Good snowstorm pattern. And there you can see it very nicely. You can see our split flow pattern here and here. And here's our 50-50 low, huge 500 low over southeastern Canada, ensuring that we would get a big snowstorm on December 2009, and there's the snowstorm map for you to take a look at. Very impressive snowstorm conditions. So that's the podcast. Don't freak out over the January 3rd or 4th possibility yet. It's really on the extreme. The ensemble support is too far to the east. It's not over. It could shift to the west. I'm just not that excited yet. Let's start from a position of skepticism and get more excited as we get closer to the event and see if that holds. This is meteorologist DT. I'll catch you on the Facebook page and on the Twitter accounts.